going to do that. Hopefully you heard. We're going to be recording the meeting, so you're aware. And with that, we'll go ahead and get started. Today, is Brian on the call yet? Brian Hadley. I don't see Brian. Well, we're going to have a USGS 3.0 program update. If Michelle, I don't see you on either. If Michelle's on, she can jump in and do that, or we will come back and do it when Brian's able to join us. We'll give a brief 3.0 for the Nation project update. And then we're fortunate today to have not only Rob Dollison, but Jason Stoker and Rick Brown to talk to us about accessing 3D elevation program data. Following that presentation, we'll have a discussion, a Q&A with those presenters. So I don't see Brian on, so I'm going to go ahead and jump down to the 3.0 for the Nation project update. Most of you know we are in a new project year, our final project year. So the final project runs May 15th, 2022 through May 14th, 2023. So that's rather significant. We've got to decide, how do we close this thing out? How do we meet the needs of the state? How do we meet the needs of the Fed? And I'm very pleased to announce we are going to be able to hold a workshop at the NSGIC annual meeting called Taking Stock of 3.0 for the Nation. We'll have a little bit of a showcase of some state 3.0 work. We will have a summary of our achievements. And the key point is we want to set some priorities for the last 7 months of the project. And also, what is that post-project vision and activity? So this is going to be a dynamic dialogue. It will be Monday morning, September 19th. So if you're interested, and I hope you are, please plan your travel accordingly so that you could be there Monday morning. And Dan Ross has been kind enough to put the annual conference URL. If you're interested and hadn't thought about it yet, he's put the link into the chat. I don't see Brian yet. Brian, are you on? Brian Hadley? Don't see Brian, and I don't see Michelle. I think we can go ahead and just do the slide. Brian provided this for me. 23 proposals in 14 states covering, this year the BAA covered 184,000 square miles. We are fortunate that this will complete statewide coverage for Maine, Rhode Island, and Utah. And the BAA is on track. The FY23 BAA is on track, expected to open in late August. So start your gap analysis and partnership building now. Start thinking about what it is you need to achieve, because this FTN, 3.0 for the Nation FTN project support, Phil and I, this is the last year we're here to help you. So figure out what you want to do to leverage this opportunity that USGS and NSGIC can provide this level of support. And I believe as always, they have a very informative webinar, and that is tentatively, maybe not so tentatively, I believe it's scheduled now for August 10th. Any of the USGS personnel want to chime in here, share anything? Claire, Drew, Carol?
Hi, Linda. No changes to your slide that I can think of. I think it's all on track.
Great. And Michelle, I see Michelle's on. Michelle, did you have anything you wanted to add? I don't think Brian's able to join us.
Yeah, I haven't heard from Brian, so that would be my guess as well. The only thing I would say is your top bullet that says 184,000 square miles is probably closer to 180,000. And I gave you that number, and I gave Brian that number, but after some updates, right now it's sitting at 180. But it changes day by day as we update projects. So we're close. We're in the ballpark anyway.
Okay. Well, thank you. Well, it's a great achievement either way, so that's great.
Definitely.
All right. We've already covered the project year in the annual conference. So We will probably put out a survey to get a head out to get some sort of a head count as to how many people are going to be able to. I want to interrupt. Jim put in the chat that it's going to complete statewide coverage for Wisconsin too. So that is outstanding. We will probably inventory the community to see who would be interested in participating in this workshop so that we can scale the meeting room and resources accordingly. So if you're on this interest group meeting, you'll get notification and information and you can respond at that time. So thanks. I also wanted to mention that it's that time of year where we update the state 3DEP profiles. The dashboard is here. You can access that from the state 3DEP info hub. Phil, maybe I will put you on the spot and ask you to put the info hub or the, if possible, the dashboard URL into the chat. That one you probably know pretty well.
I'll do that.
And there we have information about who's your state 3DEP point of contact, what's your acquisition status, do you have a plan? What are your data distribution links? Do you have education materials? This is really helpful to other states as they're developing resources for their community. So having all this in one place and being able to access it is very important. If you've not previously contributed to the 3DEP profile dashboard, the URL is here. It's also on it. It's different than the one on in the chat. Phil's the authority, so use the one in the chat. I might have an old one here. Yeah, I think there's.
I think they both work.
Okay, great.
Yeah.
If you are an existing participant, you're already represented in the dashboard. You should have a user assigned URL that you can go in and update that. And if you can't find it or you have any questions, Phil, as always, is the expert and can get you where you need to go. And he's pretty nice about it too. So please feel free to reach out to him. And with that, I am going to turn this over to Rob Dollison, who you all know is the National Map Delivery Services Lead. As I said, he's going to be joined today by Jason Stoker, who's the Elevation and Science Applications Lead, as well as Rick Brown, who is the Senior Delivery and Viewer Services Specialist. So we've got a great team on board today. And I'm going to stop sharing my screen and ask Jason to share his. And as always, please enter your questions into the chat and we will address them one by one as we, so enter them in as they come in.
Thanks, Linda.
Is everything looking okay, Rob?
Looks good.
All right.
Looks good. I think I'm done. First slide came up. All right. Well, I'm looking forward to introducing this discussion here. And I know we have a lot of slides, but I do want to encourage questions and discussions as we go. I'm very glad to have both Jason and Rick, really our LiDAR experts, both from the use and from the management and distribution of it. I rely on these two completely. So I'm going to do a little introduction and we'll be doing a little tag teaming as we go through. Hopefully that'll help make it a little more palatable late here in the afternoon, or a little later out in the East Coast anyway. So let's go on and start off with the next slide. Thanks, Jason. Now this is actually a slide Jason produced, which I am very grateful for. It's a nice summary of sort of the, what are we trying to support here in the program with 3DEP and all our and a national map and elevation data, getting it out to our customers. And I think a lot of folks are pretty familiar with the sort of triangle of sort of users, from casual users up to experts. And we try to find ways to meet this variety of user needs. And I'm sure others at the states also have the same challenge. So, I'll start a little bit over on the raster-based side. For our most casual users, we produce the US topo, and the LiDAR data is, improving our elevation-based data, which improves US topo, the contours and the shaded relief and all of that. So it all feeds into our core map product, which is pretty much accessible to anybody for use. And we also have the new application Topo Builder. We're not going to go into all of these applications, but I think it's a great next step of being able to get to our most current data, center the map where you want it, and produce a map. and know that you're getting the most current data that we have in our national map holdings. I think there's a lot of other things that will be added and built on to Topo Builder and capabilities, and we're certainly looking at new products like 100K and 250K maps to offer there, but a lot of future in that application. And so we have things like our advanced viewer for just consuming things in services and mashing up our data and exploring anywhere in the country you want. LiDAR Explorer and the TNM downloader for downloading and accessing the data, as well as going on up through then our dynamic service, eventually the uses of things like stack catalogs, spatiotemporal asset catalogs. I'm glad I got that one out. And virtual rasters, which we've had a lot of folks taking advantage of that as a neat way of accessing our elevation data. So, and over on the LiDAR point cloud, we have our point, Pottery viewer, which now lets you stream and look at the LiDAR data without having to download it. We've had other groups working with providing access to our data, grid, open topography, and others, which I know Jason will talk about. And the LiDAR Explorer really lets you visualize those, really look more detailed into the data for download, as well as visualizing it, but really get to work more specifically with our LiDAR data. And so then going up the line are some of the things more that are in works and obviously available, but talk a little bit more about the future. Things like our cloud optimized point cloud derivatives, the use of Jupyter notebooks, and direct access in the cloud. So these are all some things we'll be touching a little bit on. Not going to be demoing applications, but more just talking about just the ways of what we're doing, help access the data better and what things are coming in the future, and look forward to discussions on this. So next slide, Jason, thanks. This is just a quick summary. Hopefully most of you are aware of our products that we make available are 2 arcsecond, 1 arcsecond, and 1/3 arcsecond NED data. Those are our nationally seamless, well, formerly NED, but our nationally seamless data sets. And we still have some project-based, the 1/9 arcsecond, which is a more legacy, our 1 meter, which is we're working to fill in the whole country with all your support. The 5 meter Alaska data, IFSAR data, which has been completed. So these are sort of the core products. We offer the source LiDAR, the source DEMS, digital service models, data from the IFSAR, and ortho radar ORI data, ortho-rectified radar imagery from IFSAR as well. So just a quick review of those products. And I think I'm going to pass it over to Rick to talk about a little bit about what we've done making access to these, some of the changes to access to this data. So thanks.
Thanks, Rob. Yeah, and one thing I might mention for some that might be new information on those existing products, the seamless DIMMs, and really any of the raster products are now available as cloud optimized GeoTIFF. So that's somewhat of a change from the past. We didn't get on the slides. But a couple other things here that I'm on this slide, just a lot of folks want to keep a current copy of our DIMMs online at their own centers. And so we've implemented this current folder idea. And so the names don't change in that current folder. They're identified by the 1 degree block, and there's no timestamp added to it. So that current folder will always reflect the latest DIMMs, but won't have any timestamp. So you can run a sync and copy data easily there. But there's also a historical folder that includes not only the current, but also all the historical DIMMs, and those are time stamped. So the file names actually have timestamps on them. So just be aware of that. It's kind of a neat feature that for those that want to just keep a current copy somewhere, makes it pretty easy to do that. And then also just highlighting over in the little right screenshot there, the VRT which is a virtual raster. It's used primarily for something like GDAL that understands how to read that, but it's a VRT of the whole set. So it's kind of like a mosaic data set, but it's done in this VRT format. And so that file is available at the kind of the head of each of the seamless DIMS directories. Then the other thing is just the FTP was removed, replaced by HTTPS. This wasn't something we exactly wanted to do, but FTP was a security risk, and we had been kind of past our time to get it replaced. And so we went to HTTPS thinking that's fine, that'll work well. And then we found out from users that it is more difficult to download entire folders. So if you want to get a whole project's worth of DIMS, you still have to have a list of those files. So what we've implemented both for the LiDAR point cloud and the OPR, that each work unit directory would have a file in it that's a list of all the downloadable products within that folder. So you see over on the right, this 0 file download links.txt file. It's just a file that contains all the URL references to those downloadable products. And so that kind of helps if you really need the whole folder. And there's utilities that some links in the PowerPoint there for UGet, which is kind of our standard download manager that we recommend. And the link there, I'll take you to our instruction page. But wget is another solution, and rclone as well, that depending on how technical you are, you might find those useful as well. I think we're ready for the next slide. Just covering LiDAR Explorer, not a lot new here, but I am kind of highlighting the COP-C viewer as an option, as well as the POTRI viewer for visualizing LiDAR. You know, if you're not familiar with LiDAR Explorer, the link's down below. And it just marries together the spatial metadata and this visualization of LiDAR that's been processed through Entwine, as well as the downloadable products. And there's a button at the bottom when the data has been processed through Entwine to derive your own products using a cloud processing model and PDAL. So I think I have another slide to cover that. But anyway, the big highlight here is just a new viewer. And I know the next screenshot will show kind of the difference here. So below the black background is the POTRI viewer. And so you can barely see the LiDAR poking out there. But it was pretty hard to get your bearings sometimes if you weren't intimately acquainted with the data. And so the COP-C viewer provides a couple of options for background imagery, and that's very useful, very handy. And we're working with Hobu Incorporated to try to get some more capabilities in that and make it available to users. And then the last slide here on LiDAR Explorer is just deriving products. So this is a screenshot of if you press the LiDAR processing button, then you'll be taken to a page that allows you to draw the AOI if it's not already drawn. You can reproject the data, you can filter by the returns or by classification. And then you can choose whether you want just a LAS or a LAS file out as output, or use the raster TIFF and specify some of the parameters there. So it's a quick way for smaller areas. You're still pretty much limited in our cloud processing environment right now to about 10 square mile areas, depending on the resolution of the source data. But no more than 10. But it's a pretty quick way. You click process in the cloud, and then you can watch the requests, and as they get done, there'll be a download link available for those derived products. So quick way of kind of customizing a product instead of just downloading the raw LiDAR by yourself and doing the merges. The next slide. And Jason, are you gonna maybe take over at this point?
Yeah, Rick, I think I'm supposed to take over from here. Probably a lot of you have seen me kind of talk about this at various places, but strategically, 3DEP has been trying to get away from this download first type paradigm where in order to do anything with our data, you have to actually bring it into your local machine and process it using software. So, Rick and Rob are kind of highlighting some of the new ways that we've tried to enable some of this this work where you can actually tap into the data stream versus having to pull it down. And our focus to make this work better is really on how to best provision this data, how do we manage it, how do we store it, and how do we standardize it so you can do things in one part of the country the same way in another part of the country. So I'm going to go over some of the things that we thought maybe you guys weren't as familiar with in ways to kind of tap into this data and use it in your day-to-day work. First thing I'll talk about is this 3DEP dynamic elevation service. Rob alluded to it in that kind of pyramid graphic, and really this is our effort to provide all of our elevation data in multiple resolutions as a service that you can just plug that service directly into GIS. So for example, you can, add it. I'll show a couple quick examples, adding it into ArcMap, ArcPro, Global Mapper, QGIS. They're all offering this capability to just pull this service in because it's built in as an OGC web coverage service. So any software that supports WCS should be able to bring in this dynamic elevation service, and that way you can use our data without having to download it locally. One of the advantages of that then is then once you've pulled that WCS into your GIS, you can actually use the geoprocessing tools that are available to run derivatives off of the elevation data. But it's not what we consider necessarily our seamless product. Like we have our 1/3 and 1 arcsecond seamless product. It's the best available data sits on top of whatever's there. And so where you have those boundaries between some of our older data and the new 1 meter LiDAR, it's definitely obvious to see. So if you just, search for 3DEP dynamic elevation service, you should probably get this this technical announcement page here that's kind of explains it if you haven't seen it before. Really, the thing to pull from this page is this this HTTPS link here. This is kind of the magic service link that you can use to plug into any kind of GIS, and I'll show that in a couple other slides here. If you don't want to use your own GIS and you just want to browse the data via the web, Rick and team have built this demonstration elevation viewer that's web-based, so you can actually just go in and scroll pan around and use this dynamic elevation service just in a web browser, and the link's right here for anybody that's interested. There's multiple derivatives that can be computed on the fly from this data. So this first one we're showing is just a regular hill shade. There's also multi-directional hill shade, elevation tinted hill shade, a slope map, which people find pretty useful, aspect as well, a stretched hill shade. So another flavor of hill shades. We've got quite a few here. You can derive contours on the fly as well, and you can even define your contour interval in the box in the web. And then a cool little tool that I use quite a bit here is just you can draw a line and get the elevation profile across there, and it'll use whatever the highest resolution data is available to do that calculation across your transect. All in the web, all in the browser, which is pretty neat. Rob mentions the advanced viewer system. So what's neat about that is this service is built into that as well. And you can also add other data that have services connected to it as well. So for example, here, I'm showing a slope map underneath the NHD. So you can use some of those things, and that you don't even have to download the data. It's all viewable, and you can just use it for rendering if you want. Those of you that are Esri folks here, the easiest way to do this is an example in Pro, is you go up here and you click on connection, you add ArcGIS server connection, you input that magic HTTPS address there that I mentioned. This will pop up here and you select the 3-depth elevation image service. And then this is what will come up. So we have shaded relief as the default that comes in for all of our data. And as you can see, because we're using everything that we have as part of our holdings up in where we did the NED merge back in 2010 era when we worked with Canada and Mexico, that's all built in as well as all the data that's up in Alaska. So that's, shaded relief, that's been around for a long time, but the real power here is the ability to tap into the actual elevation data itself into it. So in order to do that, in ARC, what you do is you come up here and you go to your service, you right click, go to properties, and then you go to processing templates. And if you select none, which is kind of not quite intuitive, but you have all those options that I mentioned, the slope aspect and hill shade as well. You can pull up in these processing templates. But if you select none, you get the actual elevation data. So every pixel that's available here has an elevation, as you can see on the legend. So as we drill down and we zoom around, it'll adjust and render it based on the highest resolution data that's available in that bounding box window. So I just zoomed in a ways here. This is my house, I think is like somewhere over here. Anyway, I've got just showing here how we can bring this layer in multiple times as well. So I've got elevation, WCS, I made a copy 3 times. And then I brought in the hill shade, made that a little transparent. And then I also brought in slope and made that transparent just to kind of highlight some of the topographic features here. And so this is something that I can do. I can pan around all over the country and it will render this everywhere. The one thing, we mentioned, everybody on this call knows that, we don't have a wall-to-wall complete 1 meter data set yet. So it's good to know when you're using this WCS where the 1 meter versus the old 1/3 arcsecond data might exist. So we also have this elevation index service that you can add as well. Same kind of thing as I mentioned before. If you go over here, you can get the URL to the service. You bring that in as a WMS, and then you can overlay that on top of the WCS. And so now you can see where we have 1 meter data versus 3 meter versus 10 meter, and know when you're looking at what's being rendered on the WCS, what exists there. One of the things that was really exciting, we've talked about this several times before, was Amazon making the 3-depth point cloud data available as a public data set. So it's really allowed us to open up access thanks to Amazon supporting the ability for anybody to get access and egress to the point cloud data. We've built or had help with Howard Butler, as Rick mentioned, to build a couple applications on top of this. I'm going to show that here in a minute. But this has really kind of helped us expand the use, especially of the point cloud data. And in this case, the point cloud data is all stored in the entwined point tile format here, which is kind of a way to index the data in order to be able to stream it and view it levels of detail across the project. Kirk Waters, our colleague with NOAA, he wrote a really great blog on end-to-end point tiles. NOAA's also taken the step of converting their data to EPT as well. So he's got a nice blog, if anyone hasn't read that, about how to access and use the EPT data, both for 3DEP as well as for digital coast data. This is an application that Howard Butler helped build for us here that shows the availability of all of our projects that are in the repository right now, colored by the project itself. You know, we've got in this resource over 42 trillion points now, over 1,800 projects that are there. And this link here down at the bottom you can go to enables you to go to any of these projects and view it. Rick also showed how we've made a jump off to the same kind of thing here via LiDAR Explorer. This is just something that's just focused exactly on viewing the EPT data. So that's this has been really exciting. I've killed a lot of hours myself, you know, just surfing through our data via web browser, streaming the points, and looking at how our data looks and what we can and maybe can't do with the data before we even download it and try to build any kind of new derivative processes off of it. One of the interesting things that we found once we were able to take all of this data, let's say for a state, and just view all of it at once instead of on a project by project basis, is you know, we talk all the time about standardization and consistency across the US, but we've always operated here on assessing on a project by project basis and then integrating it together. We've never really looked at how a project really compares or relates to its neighboring projects per se. And so having this ability to bring in a state's worth of EPT data at once and view it really kind of highlights things like the difference in intensity per project, for example, kind of shows that. Another example here is, so we had a question in New Mexico if there were any gaps between projects that we may or may not know about. So I was able to take those EPT projects, string them all together into basically a command in the web browser and just say, all right, bring all these into this one view and let's look at it. And then we can see if there are really gaps in the projects here. Something that we didn't really have a very easy ability to do before we organized and provisioned the data in a way that enabled us to look at, you know, billions and billions of points across the state at a single time. So I encourage you all to look at that. I'm pretty sure we'll share these slides. There's, I have the I wouldn't call it code, but the HTTP link that brings in all of these projects for New Mexico together at the end of this presentation that you can copy and paste into a browser if you're interested. QGIS has done a lot of improvements recently, especially as it relates to bringing in point cloud data and especially EPT and the COPSI format that's going to be coming up. It's starting to get popular as well. In this case, I wanted to show how I could bring in several different projects from the EPT into QGIS at once to use and look at it. The way to do it, if anybody uses QGIS, is you come in here to you know, add a layer, you add a point cloud layer, you select the HTTPS protocol, you get the EPT link basically from that usgs.entwine.io page that I was showing before, and then you can just add that and it'll come up, and you can color it however you'd like. For example, this is, I believe this is elevation here. And so this is just me showing that I can bring in 4 separate projects from North Carolina that are all adjacent to each other in a streaming format. So I haven't downloaded any of this data. It's all streaming through here, and I'm able to look at it all at once and be able to use it either as a background. You can also start doing processing and classifications off of it as well. Taking it one step further here, I brought in the dynamic elevation service, hillshade streaming, put that as a background beneath the point cloud data as well. And now I've got all of this LiDAR data and derivative information all in one place that I can use together, use it with other layers as that are geo-referenced accordingly. And I haven't had to download any of that data necessarily, just streaming it. Rick showed through LiDAR Explorer, there's some PDAL pipelines that he set up to do some things like filtering and reprojecting the data. That makes it really easy, but if anybody is into coding here, if you use PDAL, you can set up a process using something called Anaconda. You set up this Anaconda environment, it'll go out and you can use the Entwine data with PDAL to tap into those projects and run these pipelines. So in this example here, I'm taking a data set, this Delaware Sands 2013 project, and a bounding box, and then I'm running a filter, and then I'm creating a height above ground model from it, and then I'm spitting that out as a LAZ file, all without having to download the data. The only thing that it's downloading is, well, it is actually going to download this data, but then it's going to process it as a pipeline. The next thing that we really want to enable, which Rick has taken a first step on, which is the creating these pipelines to be able to be processed in the cloud. So this example I just did where it downloaded this data from this bounding box and then ran this pipeline and created this height above ground model. And just to zoom in a little bit so you can see, the dark blue is where it's bare earth, and then you got your trees and buildings and so on. So I was able to create a pipeline that scripts this out and creates these derivatives pretty easily. So I mentioned that that's all enabled on this Entwine point tile format. The next thing that we're looking to take advantage of is this transition to COPC, the cloud optimized point cloud format. And Rick, I don't know if you want to step back in here and tell us why you're personally excited with this.
Sure. Yeah, so we've talked a lot about the Entwine point tile and how significant that is, because it allows us, it's a cloud optimized format. So that enables this streaming into the web browser for visualization and streaming without downloading first. Even these processing components. So that's all good. And it was the other part of that is Amazon agreeing to host that data for free, for us at least, in their public data set. The problem is it's still a copy of our LAS data. So our raw LAS tiles get added to the AWS cloud in a requester pays bucket. So a lot of people use it that are processing in the cloud, but then we produce this Entwine from that. And it's actually, not a one-to-one. It's each of the, it's stored in LAS tiles, but there's just thousands of them for every one of the tiles that we get actually from the contractor. So COPC is a very neat idea, and what it initially does is puts the Entwine format in each tile. So you could format a LAS file in COPC, store it, download it like if you wanted to, use it like a regular LAS, but you can also use it to stream and visualize on the web. without any additional processing. So, this is going to hopefully allow us to eliminate the extra processing step. And then there's a one-to-one. So, you can download that if you want, or you can stream it, but it's all built in. All that optimized format is built into each tile. So it's pretty exciting. And Microsoft has already converted that data to COP-C in the planetary computer. And derived a lot of products from it. So we're looking forward to doing the same with our cloud-hosted LiDAR data.
Yeah, and as Rick mentioned earlier, this is really analogous to the cloud-optimized geotiff format for rasters. So you can still have software. If a software can read an LAZ file, it can read a COP-C file. It may not be able to read the indexing or the other things, but it's still an LAZ file, just like a cloud-optimized geotiff is still a geotiff file. It's just has enhancements to it. Okay, thanks, Rick.
Yep.
All right. I was also going to show just a few highlights of some other third parties who have taken our data to the next level for us. Obviously Phil and others are well aware of what Open Topography has been able to do with big data sets. We were able to connect with them, and Open Topography for a while now has been able to tap into this data stream that we've been talking about and access the data and provide the functionality that Open Topography has when it comes to creating derivatives, in their processing environment from that data. Because they're not necessarily funded to do that for the public, and we're not really funded to do it for everybody yet either. They've had to limit the use of that for the point cloud data to only folks with the .edu email address account. But if they also have tapped into what we were talking about with the seamless layers, and anybody can go in and access that via Open Topography, the seamless rasters, and do product derivative generation off of that. I wasn't sure if people were aware of this, but NGA has a very similar system called Grid. And just this year, we were able to get NGA and US Army Corps, CREL, Cold Regions Lab, the ability to tap into the cloud as well, which was kind of a coup for NGA because of all of the security things that they have going on. They were able to tap into all of our data, and then they provide it via their Grid system. And it offers additional functionality similar to Open Topography, like reprojection, derived products. You can take several different projects together and spit out a merged point cloud or merged raster product from that. It's available to anyone. The public's able to access it. You build an account, and then they design your level of access based on what kind of user you are. So for federal government employees, we might have access to some different resources than the general public, but the 3-depth data is available, and you're able to tap into that with a Grid account, and you can use it that way. It's just another way to access our data. We're really happy to have in case something happens to our systems, the data's still out there, people are still able to access it via these other mechanisms, which is nice. For those of you that, no offense, Rob, that hate the national map or don't like to get data that way, and maybe don't like the way that we do things, ArcGIS's Living Atlas has now been able to take our dynamic elevation service and incorporate it into their elevation service, which is, world elevation service. And so the data that we're providing is available via the ArcGIS Living Atlas. What's really nice is in the past, we had to send Esri a copy of our data in order for them to update a lot of their services. Now they're able to just, whenever we update or put in a new project into our elevation service, it's automatically fed into their system and we don't have to send them anything anymore. So that's pretty cool. And then, yeah, we mentioned the planetary computer. This is pretty new. So Microsoft has this new platform that they put together. I kind of consider it similar to like Google Earth Engine, where they've providing this platform for science and applications, and they've been getting and making available all kinds of public scientific data for use in research. I'm going to risk it, and I'm going to click on this here just so we can go to it. So if you go here, you know, they've got a lot of different resources, but what's neat about this example is they're the first big cloud company, I guess, that has actually gone in and reprocessed and reformatted and created derivatives that we aren't from our data. So for example, here, if I scroll up, you know, they've created DSMs, intensity rasters, point cloud data. They've even created this height above ground model. And all of this is built on all the data. Some other examples of derivatives that they made, LiDAR classifications, and so on. And so this is I'll click on height above ground because this one's kind of my favorite here. And I'm going to be risky here and show you what this service looks like. So they kind of have it streaming here where they've computed height above ground layers, and I think it's at 2 meter resolution, and you're able to, you know, zoom in, pan around. They've done this for every data set that they've pulled down from us. I asked them to give me a different color scheme, so they created this one for me, which is I like a lot better, but I may be biased simply because it's mine. Just gives you an idea of what the height above ground. And so I had been doing something like this the hard way, you know, on a project by project basis. And what they were able to do using, you know, all their cloud compute and big data processing is do this for all of our data. The good news is that somebody's created derivative products from us that we don't necessarily have the resources to do. The bad news is that we don't have control over any of this. So if you go to the planetary computer and there's a problem with something on there, you'll have to complain to Microsoft and not to us, because we didn't have anything to do with it but make the data available. But it's a nice example to show that other folks are starting to take advantage of this ability that we've set up to make the data more accessible and do more with it than what we could at USGS. Rob, did you want to jump in here to talk about DSMs real quick?
I could. I thought maybe I think we've got some questions that have come up. Maybe it's
okay.
Before we get too far away from those, we might look at those questions if that's all right.
Sounds good.
That's great. Sean, I think you were the first one in. Sean Vaughn, would you like to ask Jason your question?
Sure. Good afternoon, Jason. It's sometimes easier to ask a question than it is to try to put it in the chat.
Yep.
Back in the slides when you were describing and demonstrating the digital elevation models, you mentioned that it's rendering on the largest elevation values at the resolution. I'm wondering if you were referring to the resolution of the viewing area or the resolution of the digital elevation model. Specifically, where I'm going with this is you probably know is that in order to get the most robust viewing environment, we would want all of the elevation values within the viewing area, the view shed, to be applied to the color spectrum.
Right. Okay. So for this example, because it's in ARC, which I'm assuming is the one you were asking about,
It
You
is.
know, you can, because it's a WCS, you can adjust this however you want. So what I've shown here, this could be, I used, as you can see here, I picked the dynamic range. So it's adjusting the color ramp based on this window. You could have it set for, you know, the absolute minimum and maximum for the entire data set. Or, you know, standard deviation, percent, you know, all those things. That's the nice thing, because this isn't a picture. This is actually tapping into the data. You can adjust all of those parameters however you want.
Yeah, that's good to know, and I appreciate the explanation, because it's really doing what anyone end user would want on, you know, if to replicate the, let's say, for a desktop environment or Arc Pro environment.
Yeah.
So that makes it pretty powerful. So you answered the question. Thank you.
Okay, great job. Let's see. Allison asks, any limits on the area of interest for the visualization tools? Not for visualization. That's kind of, you know, for both the rasters and the point clouds have this, you know, it's kind of pyramided. So it's set up so you can visualize it at whatever resolution you want. The derivatives, I believe, because some of this is, and Rick, you may have to step in here and fix me. You had mentioned the 10 square miles for the processing in LiDAR Explorer, but I believe that for geoprocessing, there may be limits to the amount that you can do to tap into the WCS. Does that sound?
I don't know for sure on the WCS side.
Okay. Yeah.
Right.
So I do know. So there's a guy down in Texas named Andy Carter who has built some scripts that are available, and I can, if you want to email me later, I can share them with whoever wants them. Where he's built this service that taps into this, and he can create a mosaic out of a huck, for example, and it's iterated and it's parallelized. So he's taking all the tiles that the window that he's able to process at one time, doing that in a parallel environment, mosaicing it together, and then delivering a whole huck at once. So there's, even though we may have limitations on what our geoprocessing servers allow you to do, there are tricks to kind of get around that. And I've been able to do hucks at a whole time from tapping into this service in Global Mapper and QGIS and things like that. So there's ways to get around that. Allison, hopefully that answered your question.
Yeah, thank you.
Okay, great. Let's see. Sounds like many private sector companies are getting the data as state partner. Okay, so yeah, these folks are not getting any of this data before it has gone through our QC process, Donovan. Everything that has made it through and is available, the partners would have already gotten a copy of this as well. This stuff only gets updated and added after it's made it through and is publicly available. So if I'm not sure I'm answering the question, but if you're a state partner with the USGS and you're having issues getting access to the data that you partnered with, I think probably the best point of contact is the state USGS liaison that works for your state, and they can help you connect there.
Yeah, and Donovan, this is a conversation that's going on in the state team as well. If you, I'm not sure if you've been part of that dialogue, but Brian is going to talk to us in August at the state team meeting about just some of the questions that the states have raised about the delivery of preliminary data and also data delivery delays. So that's a dialogue we're going to have in August. Brian, I don't know if you want to jump in or not. You may not want to jump in at all.
No, I think you guys covered it. I am a little, a little concerned to hear that. I hope that that's, if there is really cases of that, it's isolated. I think Jason made it clear that that's not what's going on in this case. But yeah, we are trying to refine and come to some conclusions internally about how we might make some changes. Working on some terminology, and there has been some adaptations to our process with switching to work units and whatnot. But really, funding partners and state partners should not be at the end of the line behind private industry when it comes to sharing data sets. That they should all be made available at the same time, and certainly I'd like to know a little bit more if there's something going on. So I guess I would leave it at that.
Yeah, and I will mention that it may look like we have, from the national level, we have all this 1 meter data available, but this index map, this may not be exactly up to date, but it kind of gives you an idea that because this is a service, we put everything together. So it looks like we have a complete picture. When you drill down, you'll see in some areas, especially when you zoom down close enough, this is really only 10 meter data in a lot of those places, at least for the rasters. On this one here, this is all the data that's been available. That's point cloud data. This would not get new data before it gets published or given to the partners. If there's an issue with partners not getting the data, yeah, Brian and state liaison can help correct that. But as far as I know, that anything that I've been showing here has made it all the way through and is publicly available. We haven't given access to other folks.
Yeah, and
Yep.
Abby, I see your comment. Again, I think this is going to be a good discussion, and you can, of course, reach out to Brian directly. But I think this will be a good discussion for our August dialogue. Rob, you want to talk to us about what were you going to talk to us about?
He's going to start on the DSM.
Thank you.
Thank you.
Yeah,
And hopefully some of you are probably aware of this data that's starting to come into USGS, but we received some funding from Congress to be able to acquire digital surface model data, especially over some of the states that are, harder for us to get some of the quality level LiDAR data that we would like. I think it's a nice product that can be used to support other science needs. Something is a companion product, but certainly doesn't meet all the needs we want from our 1 meter DEMS and the LiDAR data. But it's data that will be being made available without restriction. We're in the process of getting our first state of data. Nevada just came into us, and we'll be working at starting to get this data available out to the public and to all the partners, anybody needing this data. So it's just really the first state coming in, and we're supposed to be getting another state probably every couple months here, every month or so. So this is a new product we're working to get into our offerings. So let's just go to the next slide. Just to give you a little history a little behind it. It is a team led by NGA and includes GeoNorth and Lockheed. It's based on a lot of the satellite imagery from Worldview and GeoEye. Basically, they look for the best cloud-free imagery they could to derive the stereo viewing to derive these digital surface models. So it's being processed in a high-performance computing system using something called the Open Rosetta API for processing. We get these 10 by 10 kilometer tiles will be the product come out. Right now, I know we had quite a bit of discussion with them about filling some of the voids where there are clouds. Right now, we are using the 1/3 arcsecond NED to help fill in where there are voids. And this DSM is not hydroflattened. So with that, just the next slide, we'll just give you an idea of some of the different So between the products, between the 1 meter surface model, the elevation model data, and an aerial photo. And Jason has been looking and evaluating this data. And I was going to pass it over to him to talk more about some of what he's found in his evaluation of some of the data sets. I think both Nevada did a little work in Oregon as well, very different topography. So Jason, go ahead and take it away. Thanks.
Yeah, I'm, not to insult people here, just wanted to show you kind of the difference between what this DSM data is going to look like versus what a Barrett DEM looks like. So, because it's created from imagery, it's going to be the tops of things, vegetation, and so on. And Jennifer, I see your chat in here. You probably had this ready to go before I even presented it. As far as I know, and we can get, since we're starting to get data in from NGA, we'll get a better understanding of their actual process. But I believe that they used all available dates to get the adequate solution for each elevation point per pixel. There is metadata, which I'll show here in a minute. But just, I wanted to show people the difference between a DSM and a DEM. They are kind of stark, and the difference, the way that the processing works, it's not going to be as, I don't know if clean's the right word, but what we're used to as those of us that have looked at Barrett DMs our whole careers. This is just another example of sample data NGA provided us in Oregon. We wanted to see what the data looked like over heavily forested area, for example. So like I mentioned, since this is really kind of from imagery showing the tops of things, that's what the hillshade here kind of represents, is that you see where trees are. But you do see some nice features, so there was this clear cut here, which you can really see kind of shows up here in the DSM as well. So yeah, Jeff, when it comes to the ancillary data sets, NGA is part of their DGED process here. They also have these spatial metadata companion files that come in. One's called a source lineage mask, and then a source processing mask. And so like Rob said, where we have big holes in the data, NGA asked if they could fill in those holes with the 10 meter seamless data, just so it looks a little better. We said, sure, as long as there's a way for us to mask it out after. So we let them do that, but they also asked us about, what the size is of that they'd be able to just interpolate across and not give us our own data back. And so we kind of have these two processing masks, which kind of show how the data was created. And, they've got kind of, it's DGED specific things because that's how their setup has been for a while. So the information and the nomenclature is going to be different than much more DoD flavored than what a lot of us are probably used to, but they've done a really good job providing metadata and information onto how these processes are working. I did a brief comparison from one of the sample projects a while ago. We plan to go back and do a similar assessment to what we did this last year with the 3DEP archive, where we looked at the accuracy of 3DEP data. Plan to repeat that using a lot of the same checkpoints and benchmarks that we used for that 3DEP on these DSMs to get a better understanding of the uncertainty. NGA said that as part of their process, they did accuracy assessment compared to ISAT, and that would be provided in the metadata. You can see here, the relationship between the OPR DMs and the DSMs. OPR DMs from LiDAR, from 3DEP, is on the x-axis, and the NGA DSMs is on the y-axis. In barren lands, the relationship is really good. I believe it's under 0.5 meter RMSE. In flat open areas, I should caveat. In forested areas, obviously you can see there's going to be a lot more difference, but we we expect that kind of information. And so this is kind of a graphical example of a difference between the OPR versus the DSM. Areas in green is where the DSM is higher. And if you drill down, you can see these are buildings and trees and things like that. This is trees along the river. So that all makes sense because it's, you know, first surface kind of stuff for the DSMs. These other differences are a little more interesting. We haven't quite teased that out, but for the most part, the accuracy or comparison between the bare DMs in open is really good. And I think people will be able to take advantage of a lot of this data for different applications. As Rob said, we just got in the entire state of Nevada. So I quickly, you know, pulled that in and created a mosaic data set from that. And you can see this is the two metadata products that are coming off of that as well. And it looks like Jennifer raised her hand.
Thank you. Just wondering if you have a schedule on other states as you're on this slide talking about the preliminary data. Curious because in Minnesota, we need to consider what season the imagery is taken and or what day before people evaluate the difference between that and a LiDAR or stereo nape derived DSM, because we've seen some really big differences in the research that we did or that we're doing right now, connected to that shared polar geospatial center project that you're aware of. And I'd be happy to share with you, Jason, on some of that or help connect to Jim Klassen and others, because we do have a lot of field data to actually use against the tree heights, which is another thing. A lot of people like to normalize these digital surface models, and as soon as they do that in a place like Minnesota, you're going to suddenly have people wondering where all the trees went,
right?
Because they're not in the DSM.
Yeah, and you know, we should probably caveat, Jennifer, that we're not advocating for this data, or really USGS doesn't have a whole lot of plans except to make it available and let folks like you guys, do research and tell the public if the data is, that's right, yeah. But actually we don't have the resources. This was one of those things Congress just told us that we needed to do. And we know that there's going to be value there, but I think research like what you're talking about, Jennifer, is going to be really important for people to know what the data can and can't be used for. And so I hope that this, by making the data available, folks like you will be able to do actual good science and research on the data and publish papers and let people know what it's good for, what it's not good for, and so on. Our goal is to make the data available and provide a service to give. The goal was to get new elevation data in areas where we didn't have LiDAR, which is why it's most of the western states, for example.
Yeah, and I'll just conclude by saying that in all cases in the research that we do and shared geo is we need a ground elevation model. And so we are huge advocates for 3DEP and LiDAR, and no one has said that one replaces the other and that they all ultimately complement. And the beauty of the digital globe data set is how many dates per year you might even get over a single spot. So a snapshot and a single flat DSM is really not all that valuable.
Yeah, and we've both talked to the folks at Polar Geospatial Center, and they've been able to show how they can create multi-temporal types of things. I don't believe that we have plans on that right now, or at least we're not being directed to create time series 3D DSM data. This could be a one-time thing, but yeah, you're absolutely right that this is something that we definitely want to get out there and provide to the public for free, and let folks like you guys tell people what it can and can't be used for. And I agree, it's going to be complementary. It's not going to be a replacement for what we're doing with 3Dep for sure. But it could be another, what do you say, tool in our toolbox when it comes to 3D information down the road.
I was just going to mention, Jason, I don't have exact schedules of the states, but certainly I'd expect the dark blue states in that map to be the first ones coming through, since they were more part of the 2020 study area collection.
Yep.
And I am expecting so I hopefully we'll be getting a lot of that dark blue here between now and certainly this fall. As far as us making it available, we hope to make it available very similar ways we're making the DEM available, through those same services and templates, be able to visualize that data. But I don't have an exact time frame when we're going to get all that lined up. It's on our plans. I'm hoping we can be starting to make this available, near the end of the year, maybe a little sooner, but I'd probably get hit over the head by my team if I promise anything too early. So, but it's in our plans to start turning this around and getting it out and available for evaluation and use.
Thanks, Rob. Oh, and then I just wanted to zoom in here to show, like what Jennifer's saying, this is down in Las Vegas. So what you can see is, just from this hillshade view here, you can see buildings, but I'm zooming in more. The buildings aren't exactly perfect, so there's going to be things that this data is going to be useful for. Maybe planimetrics isn't necessarily one of them. But that's what we want to make the data available and see what people can and can't use this data for. Oh, here you go, Rob. This was, you want to, I think this is our second to last slide here. If you just want to finish up.
Thanks for bearing with us, but these were, we're hoping that the study, these study area, the first one will be by the end of 22, we'll be getting the states and territories here. We will make it as the raster data will be published on the national map, and we'll have the web coverage. And there's potential for some areas getting restricted over tribal lands. So these are all issues we'll be working with on this data, just like we have with the 3Dep data. And this is some example. Oh, that's right. There's some example applications, which I'm sure hopefully this group is fairly familiar with.
Yeah.
But thanks.
And so that's what we had for presentation wise. Oh, I did want to show here, I mentioned that New Mexico example. That's what it's just a bunch of text, so it's not very, but if it's available in the slides, we'll share the slides, Linda, and if people want to mess around with it, they can. So I'm going to stop sharing now. Think, did you want more Q&A? I think we've got some time for that.
Sorry, on mute. No, great job, a lot of information. Really appreciate the update, especially. So thank you, Rob, Jason, and Rick. You guys have been busy without you. Sitting in your living rooms getting stuff done, huh? If anybody else has questions, you know how to reach out to all of our 3Dep contacts. So, all right, I am going to go to my slides. Go to share. Thank you. Again, thank you all. I appreciate you taking the time. Just a few updates. The July info forum, excuse the typo, Michigan 3DHP, they are going to be giving us an update on their pilot project and introducing some data conundrums they've run across in that process, That'll be July 20th, and watch for registration information. That'll probably be coming out next week. Just a reminder, we're going to have the 3DEP for the Nation workshop at the NSGIC annual conference. So again, please schedule to attend if you are interested. We will also be having a Data for the Nation breakout. We use that term to address both 3DEP and 3DHP projects. So we'll have a combined breakout breakfast for that. And that is tentatively scheduled for Tuesday morning, Pacific time. Please, if you have questions, comments, you can always follow up with Phil or me or any of the rest of the team. So with that said, I guess I'll just see if there's any last minute questions. Feel free to come off your mute if you've got a question or a comment. All right, I'm seeing a lot of appreciations for the update. And with that said, Steve is asking when the video, Steve, are you referencing the recording of this presentation? If so.
Hi, yes, I am.
Okay, great. Yeah, we should have that up next week, and we will announce that to the FGD, to the, not FGDC. We will announce that to the 3DEP for the Nation interest group. This group here, we'll notify you when that information is available. So thank you.
That's great. It's really exciting. Thank you very much.
Again, I want to thank our speakers. Appreciate it. And just a reminder that the state team will be meeting again at the end of July. So thank you all for coming in and participating today.
Thanks, Linda.
Thanks, Linda. Yeah, thank you.
Thanks, Linda, and thanks to our USGS friends. Nice work.